Welcome to the IoT For All Podcast. Thanks for being here this week.
Thank you for having me here. Pleasure to be on this podcast. Been a regular listener for a while.
That's awesome. No, we appreciate that. Yeah, we're approaching almost 400 episodes, so it's been very exciting. Breadth of people we've been able to speak to. So it's a pleasure to have you, and looking forward to this conversation. So let's maybe kick this off by just giving our audience a quick introduction to you and to the company, so just to give a little more context to who they're listening to.
The CEO and co-founder of Doppelio, we are essentially an IoT test automation platform which enables the functional and non-functional testing of the software that runs on the cloud and the edge without dependence on physical devices. So the objective of the platform is to enable virtualized testing to make sure that systems are thoroughly tested before they are actually released out in the field. We work with a bunch of Fortune 500 organizations, been about 5 years in business.
I wanted to ask you a little bit about testing just to kind of give our audience more background because it's not a topic we cover a lot. But can you kind of explain a little bit more detail when you say testing? What do you mean? Like, what kind of role do you play in the testing process, and how is that really transforming the validation of connected products?
If you look at any connected product stack, you've really got three layers to it. You've got the device, the firmware with the device, you've got the connectivity piece, and then you've got the software, the application, and the platform. In the early stages of IoT, all the attention has been on the device and making sure they're connected. The software is where the value is being delivered to the customer. Consequently, the entire user experience, the commercial value of most connected products today is derived from that. So that's where the importance of software testing really starts coming in, because consequently, if anything goes wrong, there is a price to pay. Now, the problem with connected software compared to other types of software before is it is a distributed. You have some pieces of software that's running on the cloud, some is running on the edge. It's very dynamic, unlike the other parts of a connected solution, which is reasonably stable. And also to test for them, you now need to be able to test them for various data conditions, various network conditions, various load conditions. So it's a pretty complex beast. And it manifests itself in multiple ways. I mean, imagine you, for example, are trying to do a remote start on your vehicle on a winter morning. If it doesn't sort of trigger off because of a variety of reasons, it causes you discomfort as a customer. And imagine it's 9 a.m. and a million people across the country are doing that at the same time. There is latency, then there's an issue. You have over-the-air updates of software happening on devices. You've downloaded a software update and your device freezes because the update didn't happen properly. So because of the spread out nature, the number of things that can go wrong in this ecosystem has consequently increased. So which is why software testing in particular is increasingly becoming important for at least the folks who are, industry leaders in the various segments of connected products that we see.
That validation, that testing is really becoming kind of make or break factor for connected product success and even user trust in this landscape that we're seeing today.
Absolutely. So, like the examples I gave you, I mean, each of those examples are test. So, in many cases, those are B2C examples, but B2B products have an even more stringent demands on that. You're a smart metering software provider. You've got to make sure that you're certified for the scale. A medical device company, they were hitherto not connected. Now they're connected. You cannot afford failures. The consequences of failure are greater and many depending on the nature of business you are in.
I wanted to ask you also about kind of virtualization, which is something that's come up before. And can you just talk about why that's such a game changer for IoT testing compared to maybe traditional methods using physical devices or custom simulations or simulators, I guess I should say? Just talk a little bit about virtualization.
So essentially, all software development teams till today, in usual cases, are stuck waiting in many cases for a physical prototype or struggling with custom simulators. These are the two ways people really work with validating products. Now, uh, virtualization is breaking you away from dependence on physical devices. That, in a nutshell, what virtualization is basically you create exact digital twin. When I say digital twin, it's a digital twin designed for the purpose of testing. You don't really need to worry about the physics and the maths of the device. You need a perfect replica of the I/O behavior of a device, whether it be a smart meter or thermostat or vehicle telematics unit, whatever be the case may be. Now, what happens with actual devices is there are certain things that are just not feasible. If I have a physical device, I cannot test for scale. I cannot test for outlier conditions. It becomes very complicated. Even when I test for scale, it's not. So, for example, I have a single vehicle versus I'm now testing with a million vehicles. That's the situation. But it's not just a load case. Imagine I want to test a scenario where a entire neighborhood loses power and then all the smart meters come on at one shot. Now, that's not just saying I need a million, I just need 10,000 to behave in a certain way. I need some devices to send faulty data. So, whenever you're trying to test for scenarios with scale, physical devices is not possible. The other thing with physical devices is you cannot do automation, you cannot do CI/CD, and that is any software development team today, which is trying to move fast, needs to move there. So virtual testing actually lets you basically identify issues early, solve issues early without actually having to depend on all the bottlenecks that have been holding you up, and release with confidence. I mean, we use this term moving away from test and pray to success assurance because you just test that stuff. So that's really what virtualization aims to deliver.
Can you walk us through a real world scenario, maybe where you all help solve a major testing challenge in one of the industries that you focus on?
I'll give you a couple of examples. So one is one of our customers is a Fortune 100 company. They have multiple connected products, and before Doppelio, they would have each engineering team has gone out and built their own little simulator or a test bench setup, etc. And they were doing all kinds of testing. They have products which are in connected buildings, they have products in logistics, they have products in fire and safety, retail services, etc. And the ability to test for functionality as well as non-functionality varied from product line to product line. Now, what they've done is they're moving gradually. Each of their product lines is getting their setup onto Doppelio and moving away from dependence on A, physical devices, and B, also retiring some of the people who were, just uh, spending time on building simulators. They can be better deployed on building some of the software features that they're having. Another example is we're working with a leading auto OEM. They have, like most auto OEMs, multiple models and variants in the market. They're also very aggressively launching new connected features. Now, their testing engineering team is structured in a silo. So you've got the device team, you've got the platform team, the API team, the mobile team, and each of them are doing their own testing. The system testing never truly took place prior to a field trial. And consequently, they had few problems coming in. One, they were having an increase in the number of issues the customers were seeing. Second, when they got an issue, sometimes it took them months to isolate which of these four teams was responsible for fixing that issue. And now what they've done is they've set up Doppelio as like an integrated software in a loop across all these teams. So through the life cycle, they're testing against. So they've created virtual variants, virtual equivalents of all the vehicle variants out there. So when a team builds a feature, they're able to test it across actual conditions that feature will be operating in. And they're seeing a drop in actually the issues that are going out in the field. So there are two slightly contrasting examples, but I thought I'll give you a couple. There are many others, of course.
Now, let me ask you about physical versus virtual testing labs and how they kind of coexist in practice. When should enterprises or how should enterprises be thinking about the two, and when should they rely on one or the other or work, together?
I don't think there is a question of physical or virtual. They both have their roles and they should coexist because there are certain things that you need a physical lab for. You're testing your things which you need a real device in your hand for. Many your device characteristics that need to be tested physically. There are also certain conditions from a regulatory compliance, etc., that you need to satisfy in the lab. What a virtual lab, on the other hand, can complement and give you is the ability to do anything that requires scaling, anything that requires validating with network conditions, and any complex workflow scenarios that sort of come in. And many of our customers do that. So, for example, a medical device client has a physical lab for building their, designing their, developing their infusion pump, but there are connected workflows or validation for scale for their hospital clients who may actually have a few thousand infusion pumps. They just cannot do that in the physical lab. They do that on the virtual lab. Or you could have physical PLC setup in your lab for, let's say, 20 PLCs, but now you need to test it out across a larger industrial setup, bring up virtual PLCs. And similarly, we've seen other cases where like there's a client of ours who has a fire and safety system. They are able to, they've set up a lab setup which mimics a single floor, for instance. But now they want to test that across, say, 20 buildings because they have disconnected. Now you can't do that. So the way to think about it is there's always some amount of testing you should do in the physical lab, complement that with physical, and then you've got a really bulletproof setup of testing everything.
Let me ask you about the kind of the limitations that come up around simulator-based approaches with all of this. What are some of those like maybe common pitfalls that you've seen, and how does your platform-based approach help overcome those pitfalls potentially?
People often start with saying, "Hey, I know my device, I know my data. Well, let's build a simulator. How hard can this be?" But what happens is these simulator approaches fall into the trap of what is kind of oversimplification and disconnect from the real world. So first of all, what happens is initially when the things are simple, they're fine. But when you've got more complex requirements coming in, a simulator is requires caring, feeding, it takes up people. That's the number first thing. People never estimate for that. The second thing is that simulators also have everything embedded in the software. We've seen teams where which had simulators. There's a new requirement and a new release. The development team is waiting for the simulator team to upgrade the simulator, get it ready, etc. There are two things they just cannot do. One is network conditions. Most simulators assume normal network scenarios, or they don't account for the fact that there are latencies, availability, speeds that will impact a connected product. And how do you simulate that? The other thing that they miss out is load. Reason being that most custom simulators are built on tools or architectures that were designed for the web world, which tend to mimic devices as though they are users, web users who basically just click and wait. But a device is not like that. It is constantly connected. It maintains state. It communicates bidirectionally. It is not a single level communication, and you need. So consequently, simulators suffer from shortcomings as well. So basically, the problem with simulators is they start looking very straightforward. They can spiral into very high maintenance systems, which are not a true replica of the real world scenario that you need to test for. So very frequently we run into customers who replace a simulator with a Doppelio.
Now, when it comes to kind of the speed and scale that customers are looking for, how do you all help enable kind of that rapid, repeatable, scalable validation across different device types, different networks? How do you kind of handle that, and what kind of conversations do you have with customers around the capabilities there?
So one of our clients is a leader in forklifts worldwide. They've connected forklifts. They have a couple of device variants. Now, when they started talking to us, they actually initially said that look, our business is growing very rapidly. We are at a number X. We will be at number 3X. We want to run load testing and performance testing, and we need virtual devices for that. When they started talking to us, then they realized that they had another problem that their software teams were always waiting for the device releases and they were stuck. They were not able to do a good job of testing the device to cloud scenarios. So then that pointed to the fact that, okay, we have time being lost in doing all of this. They had built a simulator, but the simulator was not suitable for automation either. So consequently, they went ahead and then we implemented Doppelio out there. So now what happens is, they don't have to wait for the actual device to come in for the teams to do the testing. They now run tests in a CI/CD. The device cloud scenarios are all automated. Teams test them as they go along, so no waiting time there. And each release now is very effortlessly tested for the scale that it is supposed to be tested out for. What they've also achieved because they're able to do this through the development cycle itself is being able to catch issues early. So if I look at this as an example, they're able to both scale with confidence in terms of saying a business is growing, platforms tested for it, and the time and effort taken to test has come down dramatically.
And what role does this is kind of some things you kind of mentioned throughout, but I'm just curious about this. So, what role does intelligent automation play in accelerating kind of the DevOps, the CI/CD for IoT products? Like, how does that work?
If you have to try to do end-to-end testing of a IoT system, see, you have tooling available for the front end. There are a bunch of tools for the web, the mobile, the APIs. That part is easy to automate. The part that is missing today, Doppelio is obviously filling that, but there are not many options available, is for the device interactions and the device software itself. So now if I need to do end-to-end automation, most companies and organizations will automate the first three parts. They'll automate the front end, for anything that is not device dependent. Uh, Now that solves that part of the problem, but here's the problem it creates, that if your release has device dependent functionality, you can release only as fast as the slowest piece in your chain. So you've got a kind of a sports car running at the front end and you've got a horse cart at the back. And that really where the thing breaks down. So once you're able to automate these two pieces, the back, then you're able to run an entire end-to-end automated chain and do the DevOps CI/CD. I mean, one of our clients is uh, actually chose Doppelio, brought in Doppelio just for that specific purpose. They are a leader in heating and cooling equipment. They had everything under CI/CD. They just didn't have this piece, and they got Doppelio to virtualize all their devices, and now it runs end to end.
And when it comes to actually doing the validation, I imagine that the earlier you do that, the better it's going to be for the future success or the increased likelihood of success throughout the rest of the development life cycle, right? So what are you seeing as the ROI of moving that kind of further or earlier in the process, as maybe not everybody thinks that it needs to be that early, or kind of what are you seeing there, and what's the value that people need to be really thinking about?
I think everybody knows that catching defects early in a life cycle is dramatically cheaper than finding it later. When you do a kind of early detection or shift left of your testing, you're able to find defects earlier. So that's one obvious one. The second consequence is if you're not able to catch it in your testing, it lands in the hands of a customer. Then you've got recalls or service disruptions, etc. So there is a dollar cost of reducing defect related costs coming out of early detection. The second thing is, the second part of the business case actually steps up, because once you're doing this, you're speeding up your release cycle. There's fewer rework. You sort of, are doing, no late stage surprises. You're much more sure about your timelines. So there is a speeding up of release cycle. So different product lines have a different economic value for crunching time. Uh, Automotive, for example, could have a much greater value, or a B2B product could have a much greater value. And the third thing is that if you have issues appearing in the field, you have an organization and paraphernalia to do firefighting. That comes down. The moment the consequences of a good quality product also shows up in your services, support, and operations cost. So there are these three broad dimensions that we see people building their business cases around.
And I guess just to expand on that, what advice do you have for product leaders, QA leaders, at enterprises just beginning to modernize their IoT testing strategy? Kind of accumulation of everything we've been talking about here, obviously, but like, what are the main things that they should be taking away from this conversation as advice on how to improve their process?
Think beyond the existing IoT setup. See, because what you might have had a setup for your prior releases may not hold true for what's coming three, four, 2, 3 releases down the line. So that is one thing. So think clearly about the gaps in your approach. What kind of scale are you running into? What kind of edge scenarios are you running into? That would be my first thing. I think we often see people sort of chasing what has already happened as opposed to thinking a little ahead. The second thing, they should adopt virtualization early. Whether you want to do it through an in-house approach or use a platform is a secondary question. But very often people say, I've invested in a physical lab, that's all I'm going to do. We think that's not the right thing to do. You should start embracing virtualization and use a combination of virtualization and physical labs. Because there are scenarios which are impossible to test in the physical world. You need to bell the cat there. And third, I would say, is prioritize automation from day one, because modern connected systems evolve very rapidly. We've seen companies whose systems have become so sophisticated, or they've grown so much in scale that they just struggle to, adapt to it. And at that point of time, if you're sort of trying to, reverse think, it becomes very hard. So think of an automation strategy early and then start plugging in the pieces. That's where you are going to. So I would say these would be my three things that come up to the top of mind of what I would probably recommend.
Last thing I want to ask you before I let you go here is just with AI, edge computing, 5G, all kind of coming together, lots of new technologies coming out. What does the future look like when it comes to IoT testing? And how can companies and what are you all doing, I guess, to prepare for that?
See, right now customers are experimenting on multiple fronts. We see people doing bits of autonomy, a lot of AI at the edge coming into play. So there are pieces that are coming together. Some of the scaling probably we'll start seeing in the next year or so. The companies are still trying to, I think, get past that early phase. We are seeing it manifest itself from a validation perspective in three broad pieces. One, there are new scenarios that are coming in from testing perspective, which are going to be different. AI-driven scenarios where the test cases and scenarios differ. The second thing is a lot more about unstructured data coming into play, not just time series data. And we've already geared up for that. Today we do support multiple, formats like audio, video, and graphics. But there's more to be done there. And the third is the edge is getting a lot more complex. So I would say these are the three things around which we are trying to evolve Doppelio to say how do we sort of address this. We're working very closely with our customers on some of these things and seeing how they sort of develop.
So, where can our audience learn more about what you all are doing? Maybe connect with you if they're interested in exploring your platform, follow up with questions. What's the best way to do that?
Doppelio.com, that's our website. You can reach out to me at LinkedIn. Anybody wants to, my email is gaurav.johri@doppelio.com. Anybody has any questions can feel free to reach out to us.
We really appreciate the time. Great conversation. Good topic we haven't really had a chance to cover. So, appreciate the sharing your knowledge with our audience, and we look forward to getting this out.
Thank you very much, Ryan.